Okay, this problem is going to talk about or show you how to use vector loops to solve this particular problem. Okay, just like before, you want to determine who's moving, who's rotating. Obviously, the slot is the only thing that is rotating. Then you look for the number of special points. Okay, so in this particular case, there's a special point right here. O is a special point. A is a special point. Now, what you have to do is move along the values that you're looking for. So, for example, you're looking for the velocity of the velocity and acceleration of A. So what I'm going to do is I'm going to define a distance here, and I'm going to put a fixed point right there. So that point's fixed. So this line is fixed, and I'm going to measure a distance y, because y is the position of A because it's measured from a fixed point. The derivative of y would be the velocity, and the second derivative of y would be the acceleration. So that's why I did that. I wanted to be able to find the velocity. Okay, so the special points in this case are O, A. I'm going to call this P right here for that red point that I put there. And my vector loop then is going to start, you can start anywhere you want to. So I'm going to start at O, I'm going to go to A, and then I'm going to go to P, and then I'm going to go back to O. You can start at P, has absolutely no difference. It doesn't matter whether you go clockwise or counterclockwise. That doesn't matter at all. But here we go. So what I'm going to do is I'm going to go, starting at O, I'm going to go to A. So if you're going to go from O to A, you're going to go a distance, and I don't know what that distance is, so I'm going to define it right here. I'm going to call it L. And if you notice, L is a variable. So L changes, but anyway, I'm going to go a distance L, cosine of theta, to the right, and I'm going to go up L sine theta, up. And that's going to, if I started at O, that's going to put me at A. And so now I'm going to go from A to P, so I'm going to go a distance y, and I'm going to go down. Down is a negative j. So if you haven't figured that out by now, I is the typical right, and j is typically up, which is what I'm doing here. And then k is going to be counterclockwise. Okay. Now I'm standing at P, and I've got to go back to O, so I'm going to go a distance B, and I'm going to go to the left. Left is a negative I. So I'm back at the origin, so that's equal to 0. Okay. The next thing that you're going to do is take derivatives of this. And so if you take a derivative, remember that L is a variable, so I'll underline the variables. That's a variable, that's a variable. Y is a variable. Okay, so here we go. Taking a derivative, you have treating the first one as a product. It'll be L dot cosine of theta I plus sine theta j. That's the first term, plus it's the derivative of the first times the second term, plus the first term times the derivative of the second term. So derivative of cosine is a negative sine theta. Don't forget the chain rule, theta dot I, plus derivative of the sine is the cosine of theta, which is theta dot j. So that's the derivative of the first red term. Okay, y is also a variable, so this is times y dot j. And then b is a constant, and so is I. So when you take a derivative of that, you get 0. And that equals the right-hand side, the derivative of 0 is 0. So if you want to keep going, we'll take a second derivative of this. So it's going to get a little bit hairier, but here we go. So second derivative, we're going to do the first blue term. That would be a product, right? So that's going to be L double dot cosine theta plus sine theta plus first term times the derivative of the second term. You probably copy down what you've already had if you're neat about it. Plus cosine theta, theta dot j. So that's the derivative of the first blue term. Let's do the second blue term, so that'll be plus L dot minus sine plus cosine theta, theta dot j. Okay, so that's the derivative of, or it's the derivative of the first term times the second term. That's what that is. Plus the first term times the derivative of the second term. So here we go. Now, each of these are made up of two terms. So that would be the derivative of the sine. So I'm going to run out of room, so I'm going to copy it back over here. Okay, plus L. And I'm going to take the derivative of this piece right here. That would be the derivative of the first term times the chain rule times theta dot plus the first term times the derivative of the second term. Then I have this piece, which is product. So it'll be the derivative of the first one. Derivative of cosine is the negative sine of theta, chain rule, times the second term. Plus the first term times the derivative of the second term. All right, and then I've got this y, negative y, so that'd be take the derivative of that guy, and derivative of 0 is still 0. Okay, now check that you did the chain rule properly. So you should have a double dot in these terms, which you do. It's right there. The next set of terms should have two dots. There's 1. There's 2, that term's got 2. There's 1, and there's 2 for that guy. So he's, looks like I've done the chain rule properly. Again, this guy's got 1, 2 dots, 1, 2 dots. This guy's got 2 dots, 2 dots, 2 dots, 2 dots, 2 dots. So it looks like I did the chain rule, right? Okay, so to solve this, what you can do is you can go in and do the red equation. So you take the i's equal to the i's, j's equal to the j's. So in this case, that would be L cosine theta, L cosine theta, minus b equals 0. You can solve for the L. L is equal to b divided by the cosine of theta. That's one of the advantages of doing the vector loop, is that you can get these values and you don't have to use anything that you know from geometry. You know, triangles are easy. You could do this in your head, but if it wasn't a triangle, if the machine was something other than a triangle, you can trust the math to give you the value you want. If you equate the j's of that equation, you'll have L sine theta minus y equals 0, and so you can solve for y if you want it. Y is going to equal L. L is equal to b over the cosine of theta, that's L, times the sine of theta. So y is equal to b tangent of theta, which again you could do with a triangle, but the vector loop will tell you that what your values are. So if it's other than a triangle, if your vector loop is something besides a triangle, solving the loop equation will get you all the positions that you need. Okay, so the next thing to do is let's take a look at the blue equation. If you notice, you're going to have two values, two equations, I equal 0 and j equals 0. So you're going to get two blue equations. And in that equation, the unknowns are L dot and Y dot, because theta dot is the omega. So because it's simple angular velocity, theta dot is equal to the angular velocity. So theta dot is a given. It's omega. Okay, so let's get the blue equations. I equal I, j equal j. So that's going to be L cosine theta. Excuse me, that's L dot cosine theta. Another I is over here, negative L sine theta, theta dot. Okay, another j component is minus y dot. Oh, I'm doing i's. Okay, L sine theta, theta dot, i's, that's it. So that there's no more i's. So that equals 0. And then let's pull off the j's. So I have L dot sine theta. Here's the j here, L cosine theta, theta dot. And then you have another j term, negative y dot. Okay, so like I said, L dot and Y dot are the unknowns. So take the top one, take this one, solve it for L dot. L sine theta. Theta dot is omega divided by the cosine of theta. L is equal to b over the cosine of theta. That's L. And then sine over cosine is tangent times omega. All right, so this would be b tangent theta secant theta times omega. So that's L dot. Which you don't care, but you got it. And then solve the bottom equation, bottom blue equation, for y dot. So y dot is equal to L, that's b, b over the cosine, that's b secant of theta, times the cosine of theta. I guess I should have. All right, so b divided by the cosine of theta times L cosine, that'd be multiplied by cosine theta, times theta dot, that's omega. So that term cancels. Plus, you have L dot, which is here, b tangent of theta. Secant is over the 1 over the cosine. Cosine theta times w. It's L dot times the sine of theta. So the speed, y dot, is equal to, factor out a b times omega. First term is equal to 1 plus, let's see, tangent squared. Tangent squared of theta. 1 plus the tangent squared is the secant squared. Okay, so that is the value that you got for velocity from the special points equation as well. Okay, so now let's try to get the acceleration term. And what you want to do is solve the acceleration equation, which is shown here in black at the very top. There's going to be two equations for that, the i's and the j's. So the tricky part is just get the I and the J copied down properly. So I'm going to pause and pull them down. Okay, so what I've tried to do here is I just copied the I components of the black equation and put them down here. So this stuff here is the I, all of the I's. And then I took all of the J's of the black and pulled them down here. So I just copied them down. So I have two equations, and here the unknowns are L double dot, or excuse me, Y double dot and L double dot, because the theta double dot is equal to the alpha, which was given. Okay, so what you want to do is you want to solve these guys. And the first equation has L double dot in it, so you solve it for L double dot. And so you just take all of these terms, all of these terms here, and push them over to the right-hand side and then divide by the cosine. So I'm going to do that and then come back. Okay, so here I've just done what I indicated. I solved for L double dot. And so I end up here. I also put in everywhere you have a theta dot, you put in omega. Everywhere you have a theta double dot, you put in alpha. So that's what that one is. And then for the L, you know what L is. You solve for it out of the loop equation. L equals B over the cosine of theta. So the next thing that you're going to do is put in, everywhere you have an L, you're going to put in a B over cosine. And then you also need the L dot. Well, you have the L dot. You solve for it right here. It's in green. So it's this term right here. This is L dot. And so you can put that in here for the L dot as well. And then you'll take the L double dot, which you have here, and you're going to put it into the second equation, that one. And you'll solve it for the Y double dot, which is the acceleration. That's the term that you're looking for. So I'm going to pause, and then I'll calculate those things and come back. Okay, so here what I've done is I've rewritten it up here, and I took the L double dot right here, this whole term, and that comes in here. So this is the L double dot. And it's sine divided by the cosine gives you the tangent here. So this is sine theta times L double dot. And then this term is 2, this is L dot, omega, okay, yeah, 2 L dot, right, so there's the L dot from up here, L dot right there. So this term is 2 L dot, W cosine, so that's this term. And then here is minus omega squared sine theta, just brought it down, and then L cosine theta alpha. The next thing that I'm going to do, I'll pause and do, is here for the L dot, I'm going to put in the value for L dot, and then try to simplify a little bit. Okay, so what I've done here is just simply plugged in for the L dot. So this term here is the L dot. So that's 2 L dot sine theta omega. And then just copy this term down. This one I didn't change. And then I just simplified here, took the cosine over the cosine. So this term is this one, and then the others are exactly what they were before. So one more step, and so I'll pause and come back. Okay, so here what I've done is I've replaced all of the L's with the B over cosine. So this term is here. This term is equal to this. This one is here. And then you have this term and this term matching. You have this one is here. This one is right here. So all I did was replace the L with B over cosine. And then if you notice, the red terms are identical. The red circle terms, these are identical, so they cancel off. The green circle terms here and here become this green one right there. The blue circle terms are here. And then the final simplification, you factor out a b secant squared, and this value is exactly what you had with the special points. So that's it.